2x squared plus 5x minus 10 over x minus 1 times x plus 2 is equal or identical to a plus b over x minus 1 plus c over x plus 2. And we need to find the values of a, b and c. So notice that this is an improper fraction. We know it's an improper fraction because the highest power of the numerator is squared, is 2. And the highest power of the denominator, if I was to expand this out, is also 2. This is a quadratic, this is a quadratic, they are the same, so this is an improper fraction. That means we can do some algebraic division. I can divide 2x squared plus 5x minus 10 by the x squared plus x minus 2. So let's do that. X squared goes into 2x squared twice. Let's multiply back out. So 2 times x squared is 2x squared. 2 times the x is 2x. And 2 times the minus 2 is minus 4. Let's take that away. 2 minus 2x squared is 0. 5x minus 2x is 3x. And negative 10, take away negative 4. So minus 10 plus 4 is minus 6. At this stage, we can see that this is not going to go into this. Therefore, we know we've finished dividing, and we know that this is the whole part, and this is the remainder. So what that means is I could rewrite this fraction as 2, and then plus the remainder, the 3x minus 2, minus 6, would still have to be divided by the x minus 1 times x plus 2. Right, so we can see now, comparing it to the answer we wanted to show, just comparing this to this, hopefully you can see that the a is clearly the 2. What we need to do now is to split this up into its partial fractions, the b over x minus 1 plus c over x plus 2. So let's do that. 3x minus 6 over x minus 1 times x plus 2. Let's split that up into b over x minus 1 plus c over x plus 2. So on the right hand side here, to get our common denominator, we would multiply the b term by x plus 2, and we would multiply the c term by x minus 1. So that we've now got the same denominators throughout. So if they are all the same, then we just need to find b and c values that make the numerators the same as well. Right, to do this I'm going to find out the b and c. I'm first going to let x equal 1. The reason I'm picking x to be 1 is because that makes this term here just be 0, because I'll get 1 minus 1. And if that term there is 0, it's going to make it much easier for me to work out the b term. So substituting 1 into here, 3 times 1 minus 6 is minus 3. Substituting 1 into here, I get b times 1 plus 2. And substituting 1 into here will just leave me with 0. So 3b is equal to minus 3, which means that b has to be minus 1. So now I know that b is minus 1, I can put that in here with my partial fractions. I just need to know my c term now. To work out the c term, I'm now going to let x be minus 2. The reason I'm picking minus 2 is to make this part be 0. So substituting minus 2 into here, I get 3 times minus 2, which is minus 6. Take away 6 is minus 12. Like I say, substituting minus 2 in here will make that be 0. And I'll get c times minus 2 minus 1, which is minus 3. And now I can see that c will have to be 4. So I can put that here. And that's my answer for part A. Right, it says hence, part B says hence or otherwise expand this fraction in ascending powers of x as far as the term in x squared. So obviously in part A we showed that this is the same thing as this. So clearly it's actually this that we're going to expand, because this is much easier to do. When I say expand, the 2 is pretty much as simple as you can get, so we'll leave that alone. But we will expand the 1 over x minus 1 and the 4 over x plus 2. We'll expand each of those separately, and then we will collect up all the like terms afterwards. So let's work out each of those terms. So the 1 over x minus 1, I want to expand that. Now, in order to use the formula, which we get given in the formula booklet, which is this, notice that I want to have a 1 at the front and the x at the end. So it has to be a 1 at the front and an x at the end. So let's go back. So first thing I'm going to do, I'm going to rewrite this as 1 over minus 1 plus x. That's me just swapping those two terms on the denominator around. Just swapping those around. I'm then going to rewrite this as a power, so it's then going to be minus 1 plus x to the power minus 1. This is still a bit of an issue though, because this is a minus 1 at the front there, not a plus 1. So I'm going to have to factorise minus 1 outside. That term at the front has to be a plus 1. So if I factorise minus 1 outside, I'm allowed to do that as long as I keep that minus 1 to the power of minus 1. So factorising the minus 1 outside is fine as long as it's kept to the power of minus 1. My first term then will just be a plus 1, which is good, that's what I need. And the positive x would be a negative x now, because x divided by minus 1 is minus x. Right. Minus 1 to the power of minus 1, well that just means 1 over minus 1. So that can be turned into 1 over minus 1, which is the same thing as just minus 1. Right, I'm now going to use the binomial formula to expand all of this. We'll keep the minus 1 at the front for now. Right, so we've got 1 plus n, which in this case is minus 1, times x, which in this case is minus x, plus n times n minus 1 over 1 times 2 times minus x squared. Right, simplifying each of these then, we'll keep that minus 1 at the front there. The first term is just 1. Then minus 1 times minus x is plus x. Minus 1 times minus 2 is plus 2. Divided by 2 is just 1. We've then got the minus x squared, which would be plus x squared. Right. Now just expanding that bracket, the minus 1 times 1 is minus 1, the minus 1 times x is minus x, and the minus 1 times x squared is minus x squared. So this is the same thing as this. Therefore, in my expansion, I've got the 2 at the front. I've then got minus this. So that is what I've got down there at the bottom. Right, let's now move to the third term, and then we can collect everything together. So the third term is the 4 over x plus 2. So again, I'm going to have to do a little bit of manipulation here to turn it into the form required. So 4 over x plus 2. Let's first swap those 2 terms on the denominator. Let's just flip the x and the 2 around. Then I will move that 2 plus x to the numerator, so it's got a power of minus 1. And just like before, this term here has to be a 1. So I'm going to factorise 2 outside. So we'll leave the 4 there for a minute. Factorising the 2 outside would become 2 to the power minus 1, because it still has to be to that same power. On the inside of the brackets, the 2 has now become a 1, and the x would have to be divided by 2 as well, so we'd get x over 2, and all of that's to the power minus 1. The 2 to the power of minus 1, so that's just the same thing as 1 over 2, or 1/2. We've then got 4 times 1/2, which is just 2. Right, let's now do the binomial expansion. We'll leave the 2 at the front, and then we've got 1 plus 1 plus n times x, which is x over 2 in this case, plus n times n minus 1 over 1 times 2 times x squared. And I only need to go to x squared here, so that's why I'm not doing any more terms than that. Simplifying that then, we've got the minus 1 times the x over 2, which is minus x over 2. We've got the minus 1 times minus 2, which is just plus 2, divided by 2, so that's just 1. And then the x over 2 squared will become x squared over 4. Multiplying each of those terms in that bracket by 2, so the 2 times 1 is 2. The 2 times the x over 2 is x, or minus x rather. And the 2 times the x squared over 4 is x squared over 2. So we have just shown that this is the same thing as this. So therefore I can put that here. Right, all I need to do now is collect up those like terms. So let me just create a bit of space and then we'll do that. So a few brackets. Just being careful with the signs here. Right, so 2. Now clearly this minus here is going to flip all of these signs here. Multiplying all that by minus 1, so I'll get plus 1 plus x squared. Collect up the like terms. 2 plus 1 plus 2 is 5. We've then got x minus x, so they cancel out. And then we've got the x squared plus x squared over 2. So 1 plus 1/2 is 3 over 2x squared. And that is all of the terms of x up to x squared for this.